The rest of this lesson, we're going to take a look at how to simplify radical expressions. So we're starting with combining radicals, and as long as the index and the radicand, remember the radicand is the value under the radical, are the same, you can combine them. These would be considered like terms. So for our first example, we have two like terms. So we simply add the number on the outside. Do not add the value under the radical. Do not add the radicands together. Just add the coefficients of them. You can kind of think of the radicals like variables. If you had 3x plus 5x, it would be 8x. It's not 8 times 2x. You don't add the x's together, so don't add the radicals either. For part B, it seems like this is simplified because we don't have like terms. The radicands, the numbers under the radical sign, are not the same, so it looks like it's already simplified. However, we can simplify radicals. So remember how to put radicals in simplest form. You find perfect square factors. So for 48, a perfect square that goes into 48 is 16, and it is 16 times 3. For 27, the perfect square is 9, and we would have 9 times 3. So to simplify these radical expressions, I've got 2 for the 2 that's the coefficient in the first place, and then you can think about these as being under the radicals multiplied together. So we're using one of our properties of radicals. We're kind of working this property backwards. Property 2 right here, we started with 48, which is 16 times 3, and we moved it back to the square root of 16 times the square root of 3. So what I'm going to do on this one is take the square root of 16 and move it outside the radical, leaving that unperfect square of 3 underneath the radical. I'm going to do the same thing with the square root of 27, splitting it up as the square root of 9 times 3. The 3, that's the coefficient, will stay there. The next 3 comes from the square root of 9, and the final 3 is that unperfect square that stays under the radical. Multiplying, we've got 8 times the square root of 3 minus 9 times the square root of 3. Now that we have like terms, we can go ahead and subtract those to get negative root 3. We'll take a look at that one more time. So for 80, the perfect square factor again is 16. If you don't come up with the perfect square factor right away, that's okay. You can keep doing the factor tree, which I'll demonstrate for you on the next one. 45 is 9 times 5. And let's say on 50 you just can't figure out what the perfect square factor is, but you do know that 10 times 5 is 50, and 10 is 5 times 2. Once you see a pair of numbers, this is the value that will come out of the radical. Or you could think about it as being 5 times 5, which is 25, which is the perfect square factor. So for our first one, we've again got that 3 on the outside. Square root of 16 gives us 4, so we pull that out, leaving us with the unperfect square of 5 under the radical. Plus our second coefficient is 7. Square root of 9 is 3. Unperfect square of 5 stays under the radical. And then that last one, the 5, stays on the outside. That was our coefficient. The pair of 5s becomes a square root of 5. That's what gets pulled out. And that unperfect square of 2 is what's left over. Multiplying, we have 12 times the square root of 5 plus 21 times the square root of 5 minus 25 times the square root of 2. So in this one, you can see the first 2 are like terms, but that third one is not. So we'll combine our first 2. We'll have 33 times the square root of 5 minus 25 times the square root of 2. Next, we're going to take a look at multiplying, which is actually a little bit easier than adding because they don't need to be like terms. You can just multiply them together under one radical. So this one becomes the square root of 50, which of course we need to simplify. 50 is 25 times 2. Square root of 25 is 5. And the 2 is the unperfect square left over. Another way to think about it on part B, when we've got coefficients, we'll multiply the 3 times 5 together. For this one, because it's the same number, I can think about this one as being the square root of 6 squared. And of course, a square root and a square are inverses of each other. They cancel each other out. So I'm left with 3 times 5 times 6. 5 times 6 is 30, times 3 is 90. On the last one, I'm going to show you another way to kind of simplify at the same time as you multiply. I want to give you a couple of different options so that you can choose the method that makes the most sense to you. So I'm going to start by breaking up 15 as 3 times 5, and I'm going to put everything together under one radical. So I'm going to jump to the next number. 10 can be split up as 2 times 5, and then I've got n squared. And for the n cubed, what you want to do is come up with perfect square factors of that as well. N cubed is n squared times n. So I'm going to split that one up. So this will be times n squared times n. Pulling out all of our perfect squares, we've got 5 times 5, so that comes out as a coefficient. The square root of n squared is n. The square root of n squared is n, and everything else is an unperfect square left under the radical. 3 times 2 gives us 6 times n, and on the outside we'll simplify that n times n as n squared.